Good evening, everyone. On behalf of Kalam's Institute of Youth Excellence, ISRO Space Tutor, I extend a warm and enthusiastic welcome to all our learners, dreamers, and future explorers joining us today. I am Deepshika, student coordinator of KIYE, and I'm glad to be your host for Lecture-7 of Aryabhata Space Lecture, a year-long online lecture series aimed to bring the marvelous of space science right to your screens. This series was started to honor Aryabhata, India's first satellite, and to spark scientific curiosity among students and educators nationwide. Our theme is Space is the Next Destination. Let's explore it. And today, we continue our journey with a very special session. Those who are very new to us, Kalam's Institute of Youth Excellence is a non-profit organization that carry forward the vision and mission of our beloved Dr. APJ Abdul Kalam sir. Our goal is to inspire and guide young minds, help them grow their skills, and prepare them for a bright future. KYE is an organization leading by the students for the students. KYE has been organizing various flagship programs and initiatives to reach every corner of India. This Aryabhatta Swarna Jayanti Space Utsav is one such initiative, organized to commemorate 50 years of India's first satellite, Aryabhatta, and to inspire young minds towards space research and exploration, where you can interact with our guests through Q&A session. Let us now take a quick look at a short audiovisual presentation that showcases the vision, achievements, and impact of KYE. Now the video starts.
जश्न भारत रग रग में है जीत की आदत ऐसा हुनर दुश्मन की सलामी को सूरज हम तेरे उजाले तुझसे जुदा नहीं होने वाले आखिर तक हम सफर करेंगे शहीद जो नस नस में है हर माजी फिर बस में है इंसान के सलाम 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 सलाम
That was a memory recalling video of KIYE. Now, to give us a deeper understanding of KIYE and its mission, I now invite our passionate student leader, Miss Vaishnavi, to share a few words about her experience in KIYE. Miss Vaishnavi, the mic is yours.
Hello everyone, I am D. Vaishnavi from Vignan Institute of Management and Technology for Women. I am honored to share my experience as a student coordinator with Kalam's Institute of Youth Excellence, organization driving youth transformation since 2013. KIYE is a powerful platform that not only boosted my technical knowledge but also built soft skills like leadership, teamwork, and the confidence to take decisive, innovative. My coordinator journey has been an invaluable hands-on masterclass. Especially, I'm proud to be contributed in KIYE massive events on ongoing initiative. Vignan Vaibhav, a massive science celebrations that drew nearly 1 lakh attendees, graced by distinguished guests including CM Revant Reddy sir and Defense Minister Rajnath Singh sir. Kalam Space Convention. I coordinated this recent landmark event at GMR Arena, which hosted Group Captain Shubhanshu Shukla sir as a chief guest, was attended by 5,000 students. Inspire Hyderabad, a key event organized by KIYE for career enhancement and inspiration. Ongoing Aryabhatta Space Lectures. contributing the successful execution of this crucial educational program. If you want to join a dynamic platform to become the best version of yourself, I heartfully encourage you to join KIYE, the definite place to sharpen your skills and ignite your young mind. My deepest gratitude goes to our chief mentor, Dr. G. Satish Reddy sir, and the brilliant space tutors and Naresh Indian sir. Thank you KIYE for this extraordinary experience. Jai Hind.
Thank you so much, Miss Vaishnavi, for that inspiring journey. Now, let us take a look onto the video of Miss Drakshi sharing her experience in KIYE.
Hey everyone, I am excited to share my journey with KIYE Kalam Institute of Youth Excellence. From being an audience member to becoming a student coordinator, KIYE has helped me learn, build confidence and develop teamwork skills. I have even met inspiring personalities like ISRO chairman Maxwell. What I love about KIYE is its focus on personal growth and nation building. We are working to strengthen India's defense and make a positive impact. If you are looking for a platform to unlock your potential and become a leader, join KIYE, hurry up and be a part of something amazing.
That was a motivating video by Miss Drakshi. Now comes the highlight of today's event. It is my privilege to introduce Mr.K. Srinivasa raju, the Chief Executive Officer of Unistring Tech Solutions UTS, a pioneering company recognized for its excellence in electronic warfare and anti-drone systems. His decade-long leadership and technical expertise have established UTS in a unique and respected position in the defense technology sector. Mr. Srinivas Garu has master's degree from the Indian Institute of Science, Bangalore, and B.Tech from NIT Warangal, where he is honored as a distinguished alumni. His academic journey reflects a deep commitment to innovation, excellence, and applied research. Former scientist at Defense Electronics and Research Laboratory DLRL, a key laboratory under the DRDO, from 2003 to 2014 in specialization of electronic warfare systems and contributed significantly to the development of advanced EW technologies for defense applications. As CEO of UTS, Mr. Srinivas Garu leads cutting-edge R&D labs across critical technical domains including system design, digital signal processing, VLSI design, and development. He also oversees the human resources and training division at UTS, ensuring that the company's young engineers and scientists are equipped with the skills and knowledge to build world-class defense and electronic systems. Mr. Srinivas Garu holds 2 patents in the field of electronic warfare and radar technologies, authored several research publications demonstrating his ongoing contribution to scientific and industrial innovation. Mr. Srinivas Garu is deeply interested in knowledge and skill development research with a focus on aligning academic capabilities to the evolving needs of defense and allied industries. His work promotes the integration of research, innovation, and talent development for national technological advancement. We are truly privileged to have such an inspiring personality with us today. Sir, the virtual stage is all yours.
Thank you. Is my voice audible?
Yes, sir.
Yeah. Can you see my screen?
Yes, sir.
So before I start, I congratulate Kalam Institute of Youth Excellence for successfully carrying out the events and for the lectures that delivered so far for Aryabhata Space Utsav. So today I have around 20 plus slides describing mainly my views in how to build a stable career in Indian aerospace and defense sector. So I believe the audience are mainly students. So my content is mainly focusing on how do you build a stable career in these sectors, what subjects you should pursue, and in addition to the subjects, what projects, what type of skills you must build. So before I begin with, I would like to emphasize 2 key aspects. One is about innovation and other one is about engineers, how engineers can actually build a strong economy for the nation. So Any country's economy is measured through its GDP. So GDP is high, GDP is good. It means actually overall as a country we are producing good, and we are building the wealth. History speaks that we are good at building the products, technologies, solutions. The world has witnessed tremendous innovation that ancient Indians did. Maybe before Christ, 3,000 years, 4,000 years, up to the 1500, 1600 and all. So you can clearly see that the Indians dominated the world gross, domestic productivity. That means the overall productivity. Subsequently, like the India went into hands of foreign invaders, Britishers and all. Now again, India is picking up. So India is rising in all the sectors. So the point to be noted, it is the engineers who build the products and who build the nation, and hence who build the strong economy. So as engineers, like if you make a proper career choice in building a correct product and join the manufacturing sector like defense, aerospace, and any electronics or electrical, for that matter, any manufacturing and sector, with your innovation, with your engineering capability, if you can build a correct product, that product may create 100 crore economy, or maybe 1,000 crore economy, 1,000 crore growth for the nation. And you as a innovator, as a engineer who build the product, can create an employment for another hundreds or maybe thousands of other employees. Could be engineers, or could be non-techies and all. So yeah, now this is like India got a big roadmap in terms of rising in the GDP, but I'm considering the nature of audience that we have and the theme of the session, so I'm getting into the topic which is more related to engineers. When they have to make, for that matter, anyone who has to make a career choice can adopt this theory. So this theory, a Japanese philosophy talks about, it's called ikigai. So it speaks that when you have to build a career, you have to look at 4 dimensions of it. So you would first look at what you actually like, what kind of work you would like to do. Could you want to be, because aerospace and defense, even software guy can contribute to aerospace defense, hardware, mechanical, business management, because aerospace and defense sector requires all the talent. So what is most important to recognize that what you actually love. So that's the most important thing, the highest priority thing. And you must actually look at what you're good at in the area that you love. Let's say, for example, you love in building, like let us say aerodynamic model, a good aerodynamic model. What you further good at, in that you are good at, let's say, for example, a closed loop control system design, or the stability in that, or maybe more deeper into, let's say, the what is called a proper aerodynamic model which works with a good stability and meeting. So you are good at actually something will related to that. Or you may be good at software. So you can write a real-time software for the control system which is required for the rocket, or which is required for aircraft or something. So first you should understand the area that you love, and within that you should understand what specially you are good at. Then you should also need to know what world needs. So I have catered some of my slides talking about what type of trends are coming in the aerospace and defense, mainly in the aerospace and space sector. So you can understand like what world needs. So in the what you love and what you're good at, what world needs you to do, then you can definitely look at basically where you are being paid. See, the moment you are you are good at contributing something that naturally society needs, so you would automatically paid decently. So this is what the philosophy of ikigai. And if you want to deep dive into yourself, inner passion, and purpose that you do, you can adapt this strategy and align yourself. So this is a smart way of choosing a career path. So looking at the history of the Indian space sector, it has started with 1975 with the first satellite launch. Today, if you see the emerging opportunities in the Indian aerospace sector, you have several things to start with. Maybe anyone can easily visualize the moment you say aerospace and space, satellite design, launch vehicles, which are rockets, a lot of things to do with the different type of payloads in the space. Could they be communication payloads? maybe weather radars, maybe electro-optics, long-range camera systems, maybe something similar to the Starlink, that is a communication system, all that. And there are a lot of startups are coming with the Indian space programs. And to an extent, Indian space and defense is linked up. So this is one of the slide I borrowed from this presentation. So if you see the size and structure of the Indian space economy, so you are basically here. So launch operations, all these, they are here. The manufacturing sector is here. All the applications that whatever, maybe it is a telecom application or any application, so remote sensing, this word here. So what you need to broadly understand when you talk about an application, could be a telecommunication equipment, a radio repeater, or a navigation system such as IRNSS, which is the Indian navigation system similar to the GPS system. So application, when it covers a broad spectrum of your electronics, electrical, mechanical, engineering areas. So you may be very good at actually something, maybe building a radio. If the radio is made a satellite grade, what I mean, like if it is a space grade, then naturally you are contributing for the space sector. So we have to look at the total, the spectrum of what is that called, careers that are available for the space sector. So a lot of payloads that what go in space, like telecom equipment, radar, remote sensing, EVO, electro-optics and all, with ground-based application, if you are able to build a product with a suitable space grade engineering, you can launch the payload into space. And everybody is looking at the space sector is a fast-growing sector, with the trend that is created by Elon Musk's company. It is a lot of payloads are likely to go with reasonably less cost in the space, and they can give different services. Now, this is one of the main interests that I already emphasized, that the global, as you can see, if you can just look at in the internet and find out the number of satellites per year are increasing in the space, you would understand that space sector is growing exponentially. People are finding a lot of applications of actually going to the space, mainly in the communication, radar, intelligence, defense applications and all. So now this is what, everybody works in the space sector. That's what I mean. Like, it's not compulsory that if you have to work for the space and maybe aerospace sector, you need to be, it's not compulsory that you should be only probably a structural designer or propulsion system, rocket. But those things which occur to your mind the moment you listen about a rocket or satellite and all. But point to be noted, everything goes into it. And to a large extent today, what people are looking at, the unmanned aerial vehicles, UAVs, aircrafts, passenger aircraft technology, or military aircrafts, defense aircrafts and all. So all these, they share a lot of common things with the aerospace sector. So space sectors. This is called aerospace, whatever I mentioned, UAV and all. Space is something which you talk about, a low Earth orbits, or maybe the geostationary orbits and all, once you send. But there is a lot of commonality that people see in between, in terms of control systems, in terms of stability, in terms of aerodynamics, system, propulsion systems. All these share a lot of commonality. So the aerospace and the space sector together requires, I would say, a great contribution from the Indian innovators, because we have to address a lot of our domestic challenges, which are mainly defense and applications. If we cannot afford to take a global imported solution, probably most of you know this popular, statistics that people speak in the web, that Indians could send satellite to the Mars, which is even with a less budget comparable to Hollywood movies and all. So if we build our own, space and aerospace requirements, it will be much cheaper, and you'll be saving the taxpayers money and all. But in addition to that, the most importantly, like, you'll be having complete control on technology. If you see the numbers that what Indian Air Force has purchased fighter aircrafts, so it will blow your mind. The money is too huge. Like, when you're importing any technology, it comes with a huge money, and most of the times your upgradation needs, your future, like a decade, 2 decade needs and all, that demands even further money for unimported technologies. Okay, so getting into the space and aerospace and all requires a strong mathematics background. It's all physics mainly when it comes to, of course, the software and other elements are there, but the crux of the any aerospace or space product has the mathematics, physics. And when it comes to chemistry, the liquid propulsion and solid propulsion, it's all related to fuels, materials and all. Then if you are in engineering, then the core subjects which create you the pathway for this engineer, that aerospace and space is all, the calculus, differential equations, linear algebra and all. So of course directly the aerodynamic subject is directly relevant. But here I would like to pause and stress a point, fundamentals create the base. So if your fundamentals are weak with respect to physics and mathematics and some associated engineering subjects, no matter how specialized a tool you use, what specific packages that you use for your design, you would end up with lack of the fundamentals to fine tune or correct your system. And especially aerospace and space sector requires an extreme optimizations. You can't afford to what is that called, leave optimization variable. Unlike let's say you are designing a bus or you are designing a car, the fuel efficiency, if you talk about, let's say 14 kilometer per liter, maybe 14.5 kilometer per liter or 15 kilometer per liter for that matter, maybe still acceptable. But when it comes to the aerospace and space, the things matter like anything. So optimization, you have to do it to the full extent. That's only possible if you're very good at these fundamentals. So from the school age, like the STEM, which mainly talks about all practical based learning, people adapting, like a lot of times people are in hurry at the high school level, so they want to jump on by hearting an equation, solving an maybe IIT problem, getting a rank. But the most important is every physics principle that you learn, you should be able to appreciate, you should be able to visualize. If possible, you should buy small gadgets and apply those physics principles, learn. Today, with the advancements in AI and simulation tools, you get a lot of web-based tools where you can model the physics equation, like experiments, and get a closest feel. Nothing can replace the actual practical hands-on. But if your school doesn't permit, it doesn't have all those resources, then there are a lot of web-based tools. So you should encourage the students to do the practical physics experiments and all. If not, then web-based simulation tools. So this becomes a basic background. So if I recollect my school days and also, I was very much interested in understanding the physics. So physics. So I was reading majority of the time physics, and eventually I picked up my interest in electronics. So it is your interest and the visualization and practical adaptation of what you learned in theory is what actually matters. So in addition to that, your natural skills like critical thinking, innovative capabilities, and of course the general skills related to teamwork all matter. So as you move to undergraduate level like BE or BTech, so if you're already at that level, then you should start pursuing doing some projects with simple drones, or maybe some models, fixed wing aircrafts or drones. Rocket and delta wing, that's little challenging, like you don't get much of the difference, but there is a lot of commonality that's shared between a fixed wing control system and further a delta wing control system, which is required for rockets and all. Then if you understand any what is it called, kinematics, applying kinematics and designing a system for a particular velocity, for a particular acceleration, mapping it to a thrust, whether it could be a simple electric motor like a BLDC motor based UAV, or it could be fuel based UAV and all. So once you learn those fundamentals and get hands on, then you become eligible for getting into the aerospace and space sector. There are a lot of tools are there. Good thing is all these tools today come with student versions. They're very easy to build and make your hands dirty, and build the what is called, because a tool as such gives a lot of models. So whatever you assume it works like that, if you model in the tool, it will speak whether it really works or not. So the industry is actually evolving. A lot of things, like people are talking about reusable rockets. It's all there in the YouTube. You see that Mr. Elon Musk's SpaceX, different satellite, different reusable launch vehicles and all. So space tourism may come down the line. Now today it is seen as adventurous and only available for the billionaires and all. But down the line it may become affordable. Then satellites are everywhere now. Thousands of satellites are there. Only that Starlink system itself has got, actually, I don't know the latest numbers, but at some point it was around 4,000 plus satellites and all there in the space, LEO orbits and all. So this is a major thing. Like, if somebody is looking at, sir, do you really say that the future of aerospace and space is there? I would actually bet on this. The unmanned urban mobility, it could be manned or unmanned. Basically, the urban air mobility is what is actually coming. This one. So the unmanned urban mobility is unmanned. Is already used for logistics. You know that in United States, China, and some countries where they are already experimenting with the drones delivering the packages, goods, and all. Like, you order something on Amazon. Imagine that drone comes and actually drops it at your place. So future, this is what people show in fiction movies, but there's a lot of research already going on for the flying cars. So that's a beautiful scenario. Like, now, because you have all these traffic restrictions and all, you are forced to stay in the city. In spite you have pollution, in spite you are paying higher rents. But the moment when your flying cars become reality, you would be happy in staying 60-70 kilometers away from the city center, and just take your flying taxi and all, and just reach in 15 minutes. That's all going to be reality. Already companies have started, startups are doing their products, and I'm proud that several Indian companies, there are IIT Chennai startups are there. They're doing reasonably good proto models and all. If government regulations permit, people will come with the flying cars and they become. So VTOL technology is already there. Then drones are already there. You are seeing that drones, and all. So a lot of other things are coming. So you see a lot of synergy between the space sector, aerospace sector, aircrafts, UAVs, either UAVs of simple UAVs that people are using today for surveillance or something, or maybe big size UAVs like a flying car. So all these are there. Really, even sky is not the limit. Actually, sky is inspiring you to further innovate and to reach to the space level. So there are a lot of opportunities in India. Like, I was been with some of the closely. I know the Indian startups. They are doing reasonably good, and they have a lot of promising careers. So if you're good, the moment fundamental level, then they'll observe you, and you have a lot of other options. So I would rather, instead of going in a one way, I want to make this session more interactive. So I rushed through, and some of the slides I conveyed. So I thank Kalam Institute of Youth Excellence, and probably continue with the question answers from now.
Thank you, sir. Thank you so much, sir, for that inspiring session. Your words add value to the young minds. So now we open the floor for a short Q&A session. If you have any questions, please drop them in the YouTube live chat, and we'll address a few questions right now. I request our guest, Mr.K.Srinivasa raju, to have few questions from our audience. Sir, good evening, sir. I am Deepshika from EC department. As I am EC student, I'm curious to know, how do signal processing techniques like compression, error correction, etc., play a part in optimizing data transmission from Earth to satellite and satellite to Earth?
Yeah, fantastic question. So in fact, what you spoke is actually the heart of space sector, what it needs. So if you heard about the stories of this Voyager 1 and Voyager 2, so these are the, you must have heard that they went beyond the solar system and gave the messages, the last messages at several, billions of kilometers away. From there, it gave the messages. So it all possible with actually the communication system, error correcting coding, correcting codes, the deep usage of the what is called low bandwidth, low power signal processing techniques. This is the main thing. And today, if you see the how Starlink is able to create that magic of providing you internet anywhere on the earth. You might be in the deep jungle, or you may be in the mid of Pacific Ocean or something. Still, you can get internet with the Starlink. That is all the communication. This one. So the connection between the communication and signal processing is straightforward. The communication is an application. Signal processing lays out the fundamentals by which you will carry out. Let's say if you are doing OFDM, whenever you are doing a wideband link, you have to use an OFDM. So the signal processing algorithms of fast Fourier transform, maybe filter, FIR filter for digital filtering and all. So they become the building blocks. So they are interrelated. So the communication system, designing a proper communication system, in fact, I would say itself is the 20 to 30% of the innovation that is needed for the aerospace and space technologies. So if you just want to witness yourselves and get an example, like if you just open, nowadays it is little restricted. Earlier it used to be open. After Operation Sindur and all, it is all limited through a login. But if you have a mobile number and email ID, you can go to IDEX. IDEX is a defense portal where they post the problems. Around 6 months or 7 months before, a list of 60, 70 problems were floated for the Indian defense innovators in space. You would wonder that 20, around some 15 to 20 out of that all are related to the communication. So one naval agency wants a radio, a small size radio to go into the LEO orbit or something. Somebody wanted, this normal, the satellite TV channels and all to be streamed, something like that. So communication and signal processing will cover at least 20 to 30% of the space application payload requirements. And even if you take this electro-optics like EVO and IR systems, again the image processing route starts from the signal processing only. Your what is called whether you want to do clouds mapping from the space, either geostationary or sun stationary orbits and all image processing again goes to the fundamentals to signal processing. So specifically, if you want to take up some problem statement and solve, then look at those problem statements like very long range, low data rate links, how you can build a small battery, which are a small solar panel of very small size. Because nowadays people are talking about, satellites of almost this size, small, a very small solar panel. And it might give roughly 100 milliwatt around. So can you design a communication system within that power budget? So if you are taking such problems, then you are very close to the aerospace and space requirements.
Thank you, sir. Thank you so much. There's another question from Oishi Das. Sir, I'm Department of ECE. I want to work in aerospace in ISRO. How I'll join in aerospace?
No, in ISRO, how do you join? That you better check in the ISRO portal. But as a aerospace, so see, you have to make a choice. There is one thing. Aerospace means anything related to the UAVs, aircraft designs. Okay, all this comes into aerospace. Space is basically like once you go into the low Earth orbits or geostationary orbits and all those payloads and rockets is a space. But as I said, both has their own challenges and all. So aerospace sector is much bigger than the space sector naturally because of the application that you have. For that matter, if you see, the growing population in India requires a lot of passenger aircrafts also required. See, why our people should only the person who can afford 4,000 rupees or 5,000 rupees should travel in Delhi in 2 hours. Why not 2,000 rupees? Why not 1,000 rupees? That only comes with a lot of, because there are limited, air mobility is there. So it is all at the cost. So if you want to join a private industry working in this area, so you have to first, as I mentioned, first you have to choose the field, whether you are a hardware designer, software designer, or a mechanical designer, or an algorithmic designer, or a engine. You are good at, let's say, some engine propulsion or something. You should be first good at something. Especially these areas, I'll tell you, there are a lot of reservation on hiring the freshers. So people want some experience, but if you can demonstrate with a good project work, good maybe project work need not be practical all the time. Maybe with a good simulation project, important concepts that you have applied in solving some problems, I think you have a lot of openings. But some of these openings are not conventional to be seen in websites and all. You must little see on the web like how companies are growing, like each company is doing some innovation, and take some little more efforts in drafting your CV, sending the personal mail to that particular jobs email ID of that company, and build your case special. So unlike a typical software employee or something, people just don't publish like aerospace propulsion system designer like that. Don't expect there will be job openings and all. Maybe they're in big companies, but they will be limited. But you can definitely approach bringing out your innovation capability, so people will start talking to you.
Thank you, sir. Sir, then another question
I saw
from
an
Arjun.
interesting news like recently, just a week before and all. The first helicopter that is made in Hyderabad by Tata Aerospace this division, helicopter division, is coming up. So you can understand if complete helicopter is being built here, so it has all the technologies involved. Maybe you closely watch those companies, their job postings and all. You should apply carefully to the roles that you like, that you keep in mind. Please don't join somebody says you will get 50,000 job here, and don't jump in there. Okay. Even if you like a job which is only being paid 30,000, first you join there. You will excel there, and eventually the 30,000 will become 3 lakh. Okay. Yeah. Next.
Thank you, sir. Thank you for your suggestion. Next question from Vinay. Vinay from Mahavir Institute, sir. Is that India having radar technology that can detect B-2B bomber aircraft from USA like stealth material?
We have few counter stealth radars, but we need lot many. We have technology and we have radars. But to cover our future needs and all, we have to build several. So there is a need, constant need to innovate and improve the radars. Next.
Thank you, sir. There's another question from audience. What are your long-term goals for expanding indigenous electronic warfare and aerospace capabilities?
Yeah, we have several of these, but since I thought this is a little relevant, not relevant to the context, I did not present some of the slides. So, like what we do today is that we are only focusing, as and today, all our products that are deployed at the border. There are more than 130 systems which are there at the border, which are electronic warfare, like detection and jamming of the drones. So they are protecting all, army, air force assets, naval assets, and all against the unmanned aerial vehicles. So we are our next generation products. We are actually going beyond UAVs. So we are addressing the needs of, detecting and jamming the aircrafts, long range radars. So that's our broad strategy. To go more specific into the EW, if you talk electronic warfare. So as on today, our jammers are designed mainly considering the drones, but in future we'll be building solutions aiming towards advanced, links, advanced maybe space links, advanced ground links. So people talk ultra wideband radios. So they go to higher bands like X band and Q band and all. So we'll be building our EW, electronic warfare solutions, to spread across all. So if you're interested more about how Unistring is going and scaling up, so you can go through some of our LinkedIn postings and YouTube videos. You'd find more interesting things what we do, and we are growing very fast on this. So in the recent Operation Sindoor, there are more than 100 plus systems which were deployed at the different places. So they brought down several. Exact number we don't get because they're all military operations, but at least we know that several tens and several, maybe around 100 SALS drones were brought down, and each drone was having maybe a grenade or maybe a bomb, which if it comes and falls something, it might have done any damage.
Can I say? Thank you, sir. Sir, you have given your transition from DRDO scientist to industry leader. What advice would you offer to young engineers aspiring to contribute to defense technology innovation?
So as you can see, how the trend in India is changing. So there was a time when I was doing my BTech and all. That was time 22 years before. So that time the defense and space was mainly around the central, government organizations and all. So people who want to pursue their dreams in this sector, so they had very limited options in the private industry and more options in the government sector. Now both government R&D labs such as DRDO and ISRO and all, uh, government undertaking, or what you call as PSUs, which are under again MOD, Ministry of Defense, but they are the public sector units such as Bharat Electronics, BHEL, HAL, and all. And third, you have basically the private industry. So you have three different options to choose. Each has its own merits and demerits. So naturally, when you are into the core government, you will be having power in more power in a particular direction, but your agility is relatively less because of the government rules, regulations, and all. Agility, I mean, how fast you make decisions, how quick you do. The PSU such as Bell, HL, and they are little try to attain a balance between how a private industry works, how a government R&D lab works. because in R&D lab the focus is on R&D, not on not more focus is on the cost optimization or time optimization, but a public sector unit such as Bell and all would try to attain a balance between these two. uh, Now when it comes to the private industry, as you can understand, the private is every industry gets a DNA based on how the founder or managing director of the company will take it. So decisions are relatively much faster in the private industry. The freedom is much faster, but you will be limited by the budgets. Defense and space is actually budgets and all. But if the company that you are joining has a good cash flow and they can fund the projects and all, it will be like that. So depending on your personality and your nature, your likes and dislikes, you have to make a choice of these three. But one thing I would say, wherever you go, you have unlimited opportunities if you are good at the fundamentals, your soft skills, your innovative skills and all, and you have plenty of opportunities.
Thank you, sir. There's another question from Jayant from Srindu. How to start journey in UTS and what skills we need to learn?
Yeah, so just a second. I think I had these slides, but I just stopped it here. I'll just this again present my slides. Can you see my screen?
Yes, sir.
Okay. So see what we do, because we know that expecting experienced people who work for the defense and aerospace industry in India is not a wise thing, because experienced people you will only get when there is already industry that is established. So I have experienced people who are there in DRDO, ISRO, and maybe some senior positions. But where do I get experienced people in this? So UTS believes in identifying the engineering graduates who are just passing out from the college and who have an immense interest in the core engineering sector and product building sector, defense and all. So what we do, we have a method where you can learn the basics through certain videos which we made and we identified from the YouTube and some NPTEL lectures and all. Then we want you to learn those basics, appear for our recruitment, written test and interview like that. So these are the main roles that what we are recruiting as of now. So we have a lot of internship. In fact, in the recent one event at Kalam Institute, I was offering this that we'll be sponsoring to through Kalam Institute 100 plus students at least for the building their strong career with a scholarship. Right from their BTech second year, third year, going through intensified training programs, paid training programs, and all. We want sponsor. So this will be doing through. Once you're in touch with Kalam Institute, soon we'll get a notification for it. And this QR code, you can scan it. If you can just take a screenshot of this, if you are seeing on your screen, and save it in your computer. So this QR code will take you to a portal where you will have already UTS created courses. So with these courses, you will be learning these fundamentals in this. And these are the 4 job roles where you have a lot of openings. Now you might wonder, I am talking about some hardware design PCB, how it is connected to aerospace. See, I'll tell you, you may be a PCB designer. You are designing a small PCB for a wireless link between ground and drone, which is around some 100 kilometers away. Okay, and you are writing an embedded C code on that. Okay, or there may be an FPGA, and that FPGA is actually doing a radar algorithm on the drone itself to detect the targets coming at 100 kilometers and all. So UTS is a place where all the technical team contributions directly go into the defense capabilities. So maybe I take few more minutes of time and go to what we build the product. So these are the slides which are showing that right from 15th August 2020, it is a UTS build products through our parent company Zen Technologies, through Bharat Electronics, through DRDO. Every time when you say any event in India, whether it is 15th August or 26th January, or maybe G20 summit, or any key event that happens in India, you take it granted that the Unistring build system will be there, protecting the VIPs and other participants from the drone attacks. So, like, I would like to jump on the products that we build. Yeah, this slide is a more relevant slide. So, what Unistring is today, just a minute. So today, the Unistring portfolio consists of all the type of technologies which are required for the drone neutralization, drone detection, and drone neutralization. So you have RF based detection, you have radar based detection, you have jammers, you have image processing, video processing, and you have guns to fire on it. So we have integrated our system with the guns, anti-aircraft guns they bring down, and small sized guns. Now we are building actually, I think that slide I removed it. So we are building one product where you will send a swarm of drones against the incoming drones to neutralize all of them. It means when I am seeing that there are 100 drones are coming, so from our vehicle, like 100 drones will take off, and each one will be designated with one target, and each of this drone will go in a suicidal mode, and it will go and hit and neutralize that. Of course, this drone also gets damaged, but you will be bringing down. So this is our latest project, which will roll out by 2026 end. So it's a long-term project. So this one. So today the UTS has a portfolio of a single point agenda. Anything, whether it is through sea or through land or through air. Okay, I mean like Army, Air Force, or Navy. If there is an unmanned aerial vehicle threat, we want to detect. We want to build a layered defense solution. Layered means the jammer works at a longer range. Let's say the drone is advanced enough, it is not getting jammed, it is walking inside, still coming inside. Then you open your gun, anti-aircraft gun, shoot it at 5 kilometers, it is not still coming. Then you open your AK-47 or kind of the slide that you have seen, which will fire at 700 meters, 500 meters, 300 meters and all like that. But whereas if you are seeing that it is not a single drone that is coming, then you need to send a swarm of drones to neutralize the drones. So probably the number of drones that the number of enemy drones that Unistring systems must have brought must be in thousands by this time.
Thank you, sir. And the project mentioned by you for the UTS is so much useful in the defense. And there's another question from Kirtan Reddy. What are the suggestions for mechanical engineer student, and what are the major tools that are mandatory to learn?
Yeah, so fantastic. It's a nice question. In fact, I missed it actually emphasizing these points. See what happened, there was a rush for the IT in the Indian engineering sector. So all colleges actually started offering more courses of computer science. They offered computer science 1, 2, AI, data science, all variants of computer sciences they offered. And eventually what they did, the number of colleges who were offering the mechanical and these core subjects and all, they got considerably reduced. You would have a beautiful time coming in future if you're good at the subject and your fundamentals, because the number of mechanical engineers itself are less, and the number of applications because of the growth of manufacturing sector in India, whether it is India semiconductor mission or India IoT sector, whether it is India energy sector, defense sector, space sector, without a proper mechanical design, no product will move out from the bench to the field. Okay, a Raspberry Pi card on my bench I can use and write software, but if this card has to go into the space or onto the drone, I need a proper mechanical design which gives the strength, which gives the thermal handling, which gives all the necessary environment. So in my company, I'll tell you, we struggle more at basically the mechanical design challenges than the electronics and all. The point is again boiling to the same. So probably it is true for several other companies also. Mechanical designers need to play a very vital role in the aerospace and defense sector, because as you can understand, let's take a telecom. If it is a simple normal telecom sector, the mechanical designer designed box will be just lying to the telephone pole, and it just need to give a basic IP65 or IP67 protection that water should not go inside. Other than that, there is no complexity. Imagine the complexity that a mechanical designer design system need to bear. You are designing a part which is for the aerospace exposed part. You must have seen, like when you are when you are flying at 10,000 feet height and all, already the temperature is negative. And when you are traveling at a speed of 600 kilometer per hour to 1000 kilometer per hour, your aircraft or your aircraft cone, the front cone, is actually experiencing hundreds of degrees of heat and huge pressure on it. So in the aerospace and defense sector, the role of mechanical engineers is going to be extremely high. Now, let me jump on to, if you are good at what, actually where you fit in. For example, you are good at structural analysis. You can design basically a proper enclosure or casing for your aerodynamics object for your payload. Payload could be a camera, communication system and all. If you are good at thermal, so you have to understand, you are at a height of, let's say, Leo, 400 kilometers, 700 kilometer height you are talking about, then the environment in which it is there, it is very harsh environment. Unlike your Earth atmosphere, below the troposphere and stratosphere, below that, where already you have we have a very simple atmosphere. It is not the case there. So the challenges in mechanical engineering product design are actually much complicated in this sector. And if you are good at these things, and if you join this company, you will be paid like anything. You will be extremely treated well in those companies, and you have a lot of innovation to do. When it comes to aerospace and all, the challenges of vibration, okay, vibration, withstanding the, what is that called, load, like for example landing, like these all drones design. If I see the first 70-80% of the drone prototypes, what they witness is like, the drone landing gears or the legs, first they break. Okay, the whatever those fins and all, they break. So for a mechanical engineer, either good at structural, thermal, um, aerospace, aerodynamic, because the aerodynamic shapes which are required for high speed travel and all, you have plenty of opportunities. But you must be good at fundamentals, extremely good at fundamentals and tools. See, simple. You first you have to become good at fundamentals. Learn everything what is possible in your college. Learn from the NPTEL videos and Stanford videos, online videos. A lot of videos are there. Build specialization. See again where your interest lies. Now go to the internet. Identify the tools and projects, example projects specific to your interest. Download a student version. Learn more on it. Identify the companies either through standard job portals, or write with your CV to the specific company. That's how you can start your career.
Thank you, sir. Sir, before going to the next question, I would like to ask permission. Sir, can we have two more questions?
Yeah, please.
Yeah, there's another question from Yashwant. Hello, sir. I'm currently CSM. Is there any chance for me to join ISRO and contribute, because everything is based on physics and electronics in ISRO? So, what an AI engineer can do?
Yeah, as I said, the AI engineer can do a lot of things on the payloads, basically. Okay. So if you recollect, the one of the our drone landing, one of our space vehicle landing on moon. Okay, the project was actually, it did not work out, mainly because of that the vehicle has to make an estimate of basically the, what is that called, the distance to it, and maintain a proper speed and all. Otherwise, it won't crash. So otherwise, it will crash basically. So AI has a role everywhere. So payloads, for example, you have that image processing payloads and all, their AI algorithms are there. And AI with military application, there are a hell lot of applications are there. So there is no limit. You have a lot of applications applying the AI, image processing, radar signal processing from a space-based payload or from an airborne payload. So many.
Thank you, sir. There's another question from Divad. Sir, I am from aerospace. I am currently in first year. I have completed calculus and all the math and also aerodynamic. But I want to build real things. But as of now, I do not have 3D. How can I?
Very good question. So as everybody can understand, like, that's how you have to start. Even so, see, if you're already good at, basically you've done aerodynamics course, you've done a mathematics course. Now, for you to build a complete thing, you would require a lot of other things which you may be learning in maybe second year or third year, or you may be never learning, but some other industry role will be filling it. Maybe a mechanical design or something. Here the tools come in picture, tools and simulation. The beauty with working with the tools and simulation mainly is you can if you go into the deeper definition of a model and simulation, the model is something which takes certain properties of a system. For example, an aerospace engineer makes a model of a rocket, only the dynamics, the flight dynamics of it. So he doesn't bother about the rocket weight or propulsion, what type of propulsion and all. He will only model there is a thrust, there are some delta wings are there, there is something. So what about simulation? Simulation is like you have a model, you feed a certain inputs and observe the outputs, or probably improve the outputs to meet your application requirements. If you have built only a level of one level of abstraction, like what you say, the mathematics and aerodynamics is a one level of abstraction, you would go to a tool, something like maybe a MATLAB, or maybe any similar tool, which will give you a platform where you can apply, you can take that flight control models, where it is all in and around the mathematics that you learned and aerospace that you learned, leaving all other aspects, assuming that they are all there, and trying to build stable structures or stable systems. Like today, if you see, there are a lot of challenges that you get. For example, jet engine, which is designing with something with jet engine is more challenging because of it's a very high thrust it can give. And when you want to have a balance between jet engine and at the time of takeoff or landing and all, you need a proper algorithm where you move from low thrust to high thrust and high thrust to low thrust. Now, this is some area where you can actually take up some modeling problems and work. So, in short, as a summary, if you have to understand, you know already mathematics, you know already aerodynamics. Don't worry directly to jump on making something practical, because that would require a lot of other things to do. You directly go to a simulation tool, ask ChatGPT, like, these all I'm good at, basically, considering the established technologies and the modern applications that are emerging. Could it be UAV applications, or maybe this VTOL, like vertically takeoff and landing, but again goes as a fixed wing, okay, or something like that. What type of mathematical or control system problems I can solve? If you ask ChatGPT, it'll throw a lot of examples. Then install a tool, student version. Keep applying whatever you learn. Interpret the results. Improve your learning. Okay. Then again, apply them in the model. Make a working model. Publish a small paper out of that. You go and present. You listen from critics and you listen from people. People will encourage you. You will more align yourselves into the real world solving criteria. Again, come back to the desk and keep doing it.
Thank you, sir. The learning strategy is very much useful for young engineers, actually. Next question from Faizan Khan. I'm from mechanical department. My question is, if we have ideas and platforms, then why we are lagging behind? As we can see, GCC nations are up with flying vehicles and we are still stuck with EVs.
Okay, very interesting question. Maybe this requires much longer time. So I would probably rather pick up some other context to explain. But in a short, if you have to summary, so I'll tell you, like an average Indian's thinking. He could be anyone. He could be a politician. He could be an engineer. He could be, IAS officer. He could be anyone. The average thinking is we are we are actually like the capability of taking the risk in the profession is low relatively. It is maybe because we were under British ruling, and maybe for 200 to 50 years we were struggling for the survival itself. So we haven't still come out of that mind, and like we are still feel insecure and all. So somebody gets 50,000 per month salary also, he still feels insecure, okay, or something like that. So the point is the thinking of this insecurity are actually showing the courage, the professional courage or something. If it changes, I mean, it has to come at an average Indian level. It's not enough if one person gets it, actually, because what matters finally is this one. So it's very simple. Let's say a person who is in a government officer who is writing the specification of a product, if he can show some courage and writing, demanding good specs and saying that if I don't get the spec, I'll reject the product also, then what happens, it creates a chance, or it creates a necessity for a private industry to write that and go for it. But if people think that, okay, if I write this, if nobody becomes eligible, if one person only becomes eligible, if I give contract, if an audit committee comes, if somebody thinks that I am doing unethical, so if all these ifs and buts, if you start thinking, it will never happen. So an average Indian has to come out of that, and you have to demonstrate your professional courage. I think you pretty much understand the professional courage is different than other things. Like, see, you see that if a lot of students, especially the male students in 10+2 or B.Tech and all, they don't mind in doing footboarding. I think you see in footboarding or running bus at 20 kilometer per hour, 30 kilometer per hour. Actually, it is a life risk. Okay, but if the same person has to stand in his own classroom or maybe seminar hall and has to speak about something that whatever he likes and all, something is stopping, right? What is that stopping? Okay, so that is the problem. So it is like there is no need of having fear, but you will have fear. That's what I mean. Actually, there is no risk of coming out of your comfort zone, but people don't come out. So this is the biggest problem. But on top of that, I would say that we first wanted to make some little money. If you see all the IITs, NITs, and all, the moment they are good, they wanted to go and settle in New York, Washington, and all all the places. So first, because we all came from middle class backgrounds and all, we are a little hurry, and I don't want to wait up to 35. I want in 30s only to buy a car, and I don't want to wait up to 28. At the age of 25 only, I want to have AC in my bedroom. So that little hurry, whatever we are showing, has actually screwed up. And the brain drain problem, whatever is there, and the Indian industry was more behind getting quick money. So Indian industry wanted to do a lot of services. Like when .com came, everybody wanted to go and write code for the pizza shops, insurance companies, toothpaste selling companies, and all. We never focused about basically building a stable economy and stable product line. So that's the reason the open AI is there in United States, not in India. Okay, so we were all behind always small benefits which we get immediately. This is applicable to every engineer also. You can attribute like this. You want to make a small benefit because somebody said that here you learn Python, you go and become data science somewhere, and killing your passion. Let's say your passion is aerodynamics, your passion is something else. Somebody said that no, in aerodynamics core engineering you get only 30,000, but if you learn Python and go into some data center and data scientist, you get 50,000. You are again doing the same mistake. Okay, so it is not looking at the short-term benefits, looking at the long-term benefits, what needs. But things are improving. Last 10, 12 years, there are a lot of magical things are happening in the country. And this is the right time where the Indian youth, especially the engineers, need to join the suitable company where you have relevant skills and the passion to pursue your dreams. Things will improve, considerably will improve in the next decade.
Thank you, sir. And I also wish that our India should improve and avoid this short-term benefits. There is another question from Sheikh Asif. How important is thermal management and structural optimization in the design of UTS products?
Extremely important. Okay. I have four quick questions. If you can answer, I can give you immediately 1 lakh per month salary. Okay. So extremely important. Okay, I'll tell you, all our designs undergo second iteration, third iteration for the thermal improvement. So you can understand. Okay. Yeah. Next.
Thank you, sir. There is another question from Veena Reddy. Sir, I'm a BTech student from AIML. How can an AIML student contribute to space tech? Is it required for me to pursue masters in which relates to aerospace?
Need not be. As I said, aerospace and space sector, when you talk about the payloads, it actually has everything. A space payload could be a radar. A space payload could be a camera. Space payload could be a repeater, something like a Starlink satellite is like a repeater. It is doing a communication link. The space payload. So when you are talking about the space payload itself is like spanning into all engineering sectors in the space. When it comes to aerospace, again, a lot of things like UAVs and all there. No need of going out of your AI subject and getting into the core aerospace sector. No need. But if you can take the applications which are of high relevance to the aerospace sector, for example, if your AI algorithm, let's say military application, it is trying to identify small boats which may be only up to 10 pixel by 3 pixel size by a camera which is shooted by the low Earth orbit, and you are building such application, you naturally deserve to join some defense company or a space company which is of relevant this application. Okay, but most of the times what people understand the AI, they understand wrongly. The AI is not that simple. You download one PyTorch or some Python library and hit an example application, do it. The way, as I mentioned, the fundamentals, how critical they are in electronics, electrical and mechanical, even in AI, the fundamentals of deep neural network, the algorithms of your error function, all these classical machine learning techniques, supervised and all this one, you must be extremely good at. If you are good at only surface level using a library and calling it, you don't become suitable for the aerospace and space, because the optimization challenges might change, okay, from the conventional to the aerospace, and there may not be a ready-made package to download and install. Point number one. Point number two. When you talk about conventional AI application sitting comfortably in a laboratory with a temperature of 17 degree, working with a powerful multi-core processor of Intel i7, some processor and all, how your AI will work is different. But when the same AI has to work on a small embedded processor in a maybe UAV, or maybe a lightweight AI is needed, you should be good at trimming your AI algorithm. In fact, that's where I see most of the AI engineers in my company. They lack knowledge. So what they don't know how to actually make it small. They say, sir, I have a million parameter. I say, not required million parameter. You take only 1,000 parameters, but run in actually 10 millisecond. Because if you can't run in 10 millisecond, my closed loop control system in aerodynamics application doesn't meet your actual control system criteria. So, as an AI engineer, if you know more about the edge AI, which is mainly talking about the embedded optimization of AI, and being able to create a database within your system, not demanding internet, not demanding chat GPT APIs or Gemini APIs and all, such kind of AI is naturally required in the aerospace and defense applications. That's it. So you need not diverge into the core aerospace, which may be again challenging, but in your area, you can master through application, you can master through embedded AI, edge AI kind of thing. They are all relevant to the aerospace and defense applications.
Thank you, sir. There's a last question from Siri from Mahavir. Is that possible to make anti-drone system more portable than Zenban based? It will be handhold model.
Yeah, there are portable systems are made actually. They are not there in the website. There are portable 10 kg, 20 kg, 30 kg variants are made. So they are being used, but naturally they'll have lesser ranges compared to the bigger systems. And again, it comes in the miniaturization. For example, let's say you have 5 PCBs. In PCBs, printed circuit boards. So if you want to make portable, if you can make a single of all of them, it becomes size and weight reduced. So achieving portability is the design challenges in RF, the design challenges in mechanical, the design challenges in electrical. With that, we are able to build the solutions. They are coming.
Thank you, sir. Thank you for thank you for that interactive conversation. Your answers to our young mind questions are inspiring. As we come to the close of this remarkable session, I invite Miss Siri to present the vote of thanks. Miss Siri, over to you.
Thank you, Deepshika. Good evening, everyone. On behalf of KIYE Foundation, I'm Siri, BTech graduated Aeronautical Engineering, along with entire organizing team of Aryabhata Space Ucho Lecture Series 7. I extended my deepest gratitude to our esteemed speaker, Mr.K. Srinivasa raju sir, CEO of UTS, for such an inspiring session on career building and space technologies defense. Sir, your words have truly ignited a scientific curiosity among of the students and the educator, encouraged many of dream bigger and aim higher in the field of defense and space technologies. A special thanks to Dr. G. Satish Reddy sir, former chairperson of DRDO and mentoring of KV Foundation. Dr. V. Narayanan sir is the chairman of ISRO,
And Dr. Prakash Chauhan sir is the director of NRSC ISRO. Their constant guidance and mentorship is encouragement, which is continues to inspiring the KY Foundation and the Aryabhata Space Lecture Series. This session will be a powerful reminder that is the space is next destination and we must be explored together. Before I conclude, I warmly invite everyone to stay connected with us for upcoming invitations. Join our WhatsApp channel, subscribe our YouTube channel, follow us on Instagram. Visit our official website for future updates. Please mark your calendar. Our next Aryabhata Space Research session will be held on 15 November 2025. We looking forward your active participation once again. Let us carry forward the legacy of Aryabhatta and Dr. APJ Abdul Kalam by nurturing a scientific temper and encouraging innovations and building knowledge in a driven future. Thank you once again. Jai Hind.
Thank you,
Yeah,
Siti, for
thank
those
you.
wonderful words of gratitude. I would like to end this session by extending heartfelt thanks to Dr. G. Satish Reddy sir for mentoring KIYE, followed by sincere gratitude to ISRO Chairman Sri Vinarayanan sir and to NRSC Chairman Dr. Prakash Chauhan sir for their constant support and guidance. We are truly honored by their encouragement towards Aryabhatta Swarna Jayanti celebrations organized by KIYE to commemorate 50 years of India's first satellite Aryabhatta and to inspire young minds in the field of space research. I would also like to take a moment to appreciate one of our incredible supports, UTS. Every year, they have been unconditionally supporting KIYE, and we are truly grateful for their trust on KIYE. A big thank you to Mr. K. Srinivasa Raju sir and Mr. S. Nagendra Babu sir for their continued support, and a special shout out to Mr. K. Srinivasa Raju sir, our guest speaker today. Thank you, sir, for graciously spending your weekend, holiday time with us, sharing your invaluable insights and expertise. We truly appreciate your time and contribute to make this event a success. And of course,
Thank
I
you.
thank everyone who joined us. Thank you for being part of Lecture 7 of Aryabhatta Space itself. Let's continue this exciting journey together as we explore new things in science and space. I request everyone to subscribe our YouTube channel, KY Foundation, for future sessions and updates. Join our official WhatsApp channel for the latest announcements and updates. Let's stay connected, stay curious, and keep reaching for this task because truly we strongly believe that space is the next destination. Let's explore it. Have a wonderful evening, everyone. Thank you. Jai Hind.